Hey everyone, so on this last video on multiplication, I'm just going to talk about one last strategy that we can use for multiplying numbers and even multiplying bigger numbers. Now, my personal favorite is the one I talked about in the previous video, this distributive law type of way, but we can actually use the idea that multiplication is commutative and associative. It works this in the same way it did with addition. So remember, multiplication and addition kind of go hand in hand. We talked about this at length in the first video of the topic on multiplication. And understanding this can lead us to some pretty useful extra strategies for solving multiplication questions. Now, these all work to make the numbers smaller, these kind of smaller bite-size multiplications that we already know from our times tables. And then this allows us to break down these numbers and then multiply a lot easier. Now, I'm going to start just by quickly showing you why these are commutative and associative. I talked a little bit in the first video about the idea of commutative, but let's just do this one more time. So if I wanted to show that 2 times 4 is the same as 4 times 2, well, let's look at how we visualize these things again. This is telling us that I have two groups of 4. That's what multiplication tells us in the end. Now, two groups of 4, I can write this as 1, 2, 3, 4. I've shown my 4 here, and I'm going to write another group of this. So the same thing, just down here. 4, I have two groups of 4. And if we count how many we have here, I can count 8 here. So 1, 2, 3, 4, 5, 6, 7, 8. I have 8 here. So 2 times 4 equals to 8. And 4 times 2, I can show this as 4 groups or 4 lots of 2. Let me show that here. So I have 2 red circles, and I want to show 4 groups of this. So I have a second group, a third group, and a fourth group. So I have, if I show this here, 4 groups of 2. And if I count these again, I get 1, 2, 3, 4, 5, 6, 7, 8. I get 8 in total for both of these. So therefore, I can say 2 times 4 is the same as, it's equal to 4 times 2. And I encourage you guys to try it with this visual method as well for some other numbers. You can say, for example, 3 times 4, or you can try 5 times 6, and you'll see that you always get the same amount of these kind of circles if you draw it in this way. You're always going to get the same result. Okay, so this is the commutative law, and we've shown that the commutative law works for multiplication. And we kind of assumed it would because multiplication has deep ties to addition. So let's just use what we know already about multiplication to try to prove the associative law. So the associative law tells us that we can multiply or add in pairs and then do the operation with the other number. And it doesn't matter which pairs we multiply or add first, we're going to get the same thing happening. So I'm going to show this with an example of, let's say, 4 times 2 times 3. Okay, so 4 times 2, I'm just going to copy and paste this one I had here, because I can't be bothered drawing this out again. So if I copy paste this thing here, copy and paste, okay. So I have my 4 groups of 2. So my 4 lots of 2 here, I've done this multiplication first. So that gives me 8. This gives me 8. And then timesing by 3, that means that I'm taking 3 lots of my 8 that I already have. Now, with the commutative idea, you can see that it doesn't matter which order we do these, we're going to get the same answer. Now, if I duplicate this another two times, so I copy, I paste. So here I've taken 2 lots of my 8, and I've taken another lot of my 8. I now have, if I just shift this down, I have 3. Let's do another color. 3 groups of 8. Cool. So I hope that makes sense how I've shown that visually. Here, there's just an extra multiplication being done. So 4 times 2 gives me 8. And then taking 3 lots of that 8, let's count how many we get. That gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That gives me 24. So let's hold on to that idea. 8 times 3 gives me 24. What if I changed the order that I times this by? So I'm talking about the associative law here. What if I did 4 times 2 lots of 3? So say I did this bit first. Now, 2 lots of 3, 2 times 3, I can write that as 2 groups of 3. So if I have my 3 here, and I take 2 groups of that, I'm going to get this thing here. I have, let's write it down again, 2 groups of 3. I can also write this as 3 groups of 2. The perspective doesn't matter. I'm going to get the same thing because we said before that the commutative law applies to multiplication. So I've done this bit here. So 2 times 3, if I count, I get 1, 2, 3, 4, 5, 6. That gives me 6. Now, let's take 4 lots of 2 times 3, or 4 lots of 6. So I'm going to duplicate this thing here, and I'm going to make it so I have 4 groups of this thing here. So if I draw this here, I have my second group, I have my third group, and I have my fourth group. Cool. Okay, now let's count these. And if what we've been doing so far is correct, then we should get the same number counted. We should get 24 again. But let's just double check that. I don't want to spoil the fun too soon. Mathematics is all about investigation, guys. So we want to find this stuff out for ourselves. We're not just going to take blindly what people tell us about timesing. We want to explore it for ourselves. So here I have, 4 groups, because I've taken 4 of my thing here. Now, let me color coordinate that. I have 4 groups of 1, 2, 3, 4, 5, 6. I have my 4 groups of 6. Hopefully you can see that I've just taken my thing here, 2 times 3. I've done that multiplication first, and I've ended up with this here. And now taking 4 lots of that, 4 groups of that, I've gone 1, 2, 3, 4 groups of the 6 red dots that I figured out before. Now, if we count all of these up in total, take a deep breath for all this counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So, by taking 4 lots of 6, or 4 times 3 times 2 from the question, I'm going to get 24. So the associative law works for multiplication. Now we're going to use this idea just to try a tricky question with multiplication. So my final example, this is technically, I guess, example 1, because we've shown that both the associative and the commutative law work for multiplication. So let's apply this to a question. 55 times 20. So I'm using really big numbers here, right? So what I want to do is I want to split these numbers up. I want to break these down into their factors, the numbers that make them up, based on what we know about our times tables. And then I'm going to use both my associative and commutative law. So 15, if we remember from our times tables, I can make that from 5 lots of 11. And 20, I can make from, let's do this in a different color, 2 lots of 10. So with the commutative law, I know I can shift things around. And the associative law, I know that it doesn't matter what order I multiply these in. So I'm going to group these 2 smaller numbers and find what I get when I times those 2, because it doesn't matter what order I times in. So I'm going to do here 5 times 2 times 11 times 10. Now 5 times 2 gives me 10, and then timesing 11, timesing by 10. So now I can multiply these all together. Now I know these are big numbers still, but we can go through multiplying them in any order we want. So I'm going to group my 10 and my other 10 and times those first. So I'm going to do 10 times 10, and then I'm going to take 11 lots of that. So 10 times 10 is like adding 10 by itself 10 times. Or from our times tables, we just know that this is 100, right? So 10 times 10 gives me 100. And this I want to multiply by 11. Now here, the number's kind of big, so I'm going to go back to what I know about my distributive law. I'm going to break this 11 down into 10 and 1. So in the end, we always kind of go back to our distributive law anyway. Now, if you had a calculator, which you'll get from years 8 onwards, this will become a lot easier. But this is like 100 times by 10 plus 1. Okay, cool. So what we learned from our distributive law is that we can times each of these together, then add them at the end. So 10 lots of 100, that's like saying 100 plus 100 plus 100 plus 100 10 times. So 100 plus 100 gives me 200 plus another 100, 300. And you'll notice that when you add all of these up, we're going to get 100 times 10, 10 lots of 100 gives me 1,000. And then to that, I'm going to add what one lot of 100 is. Well, one group of 100, anytime I times something by 1, that's just going to give me the number because there's only one group of it. So I'm going to add 100 here, and I get left with 1,100 when I do the addition. So this was just a little video to show you another strategy to help us with our multiplication. And in order to understand this strategy, we need to understand that my multiplication covers both my commutative and associative laws. So both of these laws that we talked about in addition apply to multiplication as well. And this gives us another strategy to work through some of these harder multiplications. So thank you so much for watching, guys. I'll see you in the next video.